All right, ladies and gentlemen, we've got a little bit of information problems to do here. Lesson 2.2, adding rational numbers. Remember, rational numbers, we can write them as fractions. So that's a hint there for you, fractions. Now, we want to make sure that you don't have that fear of fractions, and that's why we're going to go ahead and practice this and continue to practice it. So our essential question is, how can you use what you know about adding integers to add rational numbers? So remember the skills that we've been working with that. Adding the opposite, the rules. So our objective today, add rational numbers. So I can add rational numbers. So in order to add fractions, elementary school, you were supposed to have learned again that they need to have the same denominator. And one of the kind of tricks, and sometimes it didn't work out very well, that students would just multiply the denominator. So 3 times 6 would give you 18. Now, that is a common denominator, but if you notice the instructions, it says in simplest form. So if we can get a least common denominator, that's going to make it even easier. So the way I teach my own kids at home again is, well, a 3 can change into a 6 if we simply multiply it by 2. So our LCD is 6. Let's go ahead and say the first fraction, we're going to multiply by 2, because that'll give us a denominator of 6. So if I do 3 times 2, I need to also do 8 times 2. So that's going to give me 16, or negative 16. Again, if you want to move that negative sign up just a little bit. The great news again is that the second fraction got to stay the same, so a little bit less work. So now we're going to recognize, well, if my denominator gets to stay the same, what happens with my numerators? Well, it's just a basic integer addition problem from what we did back in chapter 1. So it says negative 16 plus 5. So remember, I'm going to take the difference, which is 11, and I'm going to take the sign from the greatest absolute value. So I'm going to get negative 11 over 6. Now, that is a fraction in its simplest form, so we're going to stop there. If we asked you to write it as a mixed number, you would have to figure out, well, is it 1 whole, 2 whole, and so on. What would the numerator be? So maybe you're thinking, well, Mr. Maria, I know it's going to be negative, and it's going to be negative 1, because 6 times 2 is 12, and I don't have 12 or 13, I just have 11. So it would be negative 1 and 5 over 6. All right, for this one here, ooh, they already have the same denominator. That's fantastic. But let's go ahead and practice, just like we did in lesson 2.1, converting that mixed number to an improper fraction. So what we're going to do again is take our denominator 3, multiply it by a whole number 6, and add the numerator 1. So right there. Remember, it's still negative, so don't worry about the negative sign right now. 3 times 6 is 18, add 1 is 19. So I'm going to go ahead and write negative 19 over 3. Second fraction gets to stay the same. Excellent. So same denominator allows me to combine it. Negative 19 plus 20, different signs, which means go ahead and subtract. Gives me a 1. Greatest absolute value would be the 20, so it is positive 1/3. Very nice. Remember, you could always back up the video, pause it, whatever you need. But that's silly. It showed up twice. There we go. Example 3. Okay, so if you notice, this is a combination of both. So I've got different denominators, so I'm going to have to figure out what the LCD is. I am going to have to write them as improper fractions. So let's go ahead and see if we can do that first. 8 times 2 is 16, add 1 is 17. 17 over 8. All right, the next one, 3 times 3 is 9. There we go. 3 times 3 is 9, add 2 is 11. So it's negative 11 over 3. All right, now that I have it in a better looking form, I can think about the LCD. Well, if you notice, 3 is a prime, and 8 is really just a bunch of 2's. So that's going to be a 24 for the LCD, which means both fractions have to change. So to get a 24 for your denominator, what are you going to have to multiply this by? Well, isn't it just the other number? 8 times 3 is 24. So yeah, go ahead and multiply by 3. Go off to the margin if you need to do 17 times 3. But if you got it in your head, it is 51. Now, our second one might even be a little bit easier. Well, 3 times 8 is 24, so 11 times 8 is negative 88. Excellent. So we notice same denominator, 24. So now it's a repeat from chapter 1, looking at the numerators again. 51 and negative 88. In order to combine those, add those, I need to actually go ahead and subtract and take the absolute value or the sign from the greatest absolute value, which of course is going to be negative because negative 88 has a greater absolute value than positive 51. So you can mentally subtract. You can go to the margin if you need to. 88 subtract 51, that is going to be negative 37 over 24. Now again, that is a fraction in its simplest form. If we wanted a mixed number, you would ask yourself again, well, how many times does 27 go into 37? Well, it's one time. There are 13 pieces left over, so it'd be negative 1 and 13 over 24. But again, trying to get a common denominator, make it a little bit easier for us. All right, we've got some great decimal problems here. So the rules still apply. I'm going to subtract because they're different signs. Going to take the sign from the greatest absolute value. And a little hint over there is line up the decimals. So if you need to, sorry, my nose is all itchy. Just line it up like an elementary problem. You probably started doing this maybe, was it fourth grade, fourth grade? When you subtract, you're going to get 1.3. Now, the reason it's 7th grade is because you had to use your different signs, so our answer would be negative 1.3. Because again, the negative 2.1 would have the greater absolute value. On this problem here, again, we're going to line up our decimal numbers, but if you notice, they're both negative, so we get to really add them together, and it stays negative. So again, practicing our integer rules, even though it's a decimal form here. If you need to, you can put that little 0 underneath the 5, like that. So again, both negative. It says add them because they're the same signs. So we got 12.45, but we know the answer is going to be negative because it keeps the same sign. So again, it's great practicing the elementary skills to make sure you still have them, but we're using our 7th grade thinking with our signs. All right, this one here. Before a race, you start 4 5/8 feet behind your friend. So it means your friend is in front of you. At the halfway point, you are 3 2/3 feet ahead of your friend. Excellent. What is the change in distance? So you can go ahead and make a number line if you want to. Or really difference, because the change, difference, something's changing, difference, that means subtraction, right? So we're going to go ahead and say 3 2/3, that's the end result. And you're going to subtract 4 5/8, but remember, it's really like it's negative 4 5/8 because you're behind your friend. It's kind of like maybe the race cars where, you know, you got some cars starting behind the people in the front of the pack. So right there, negative 4 5/8, that's the true difference where someone would be able to understand it. Because some students may just say 4 5/8. All right, now that we got it, we can do adding the opposite, which is another skill from chapter 1. And then let's go ahead and change them into improper fractions. So 3 times 3 is 9 plus 2. Hey, that's a repeat, right? 11 over 3. And then your other one, 8 times 4, 32. Add 5, 37. So 37 over 8. Now, you're going to get some pretty big numbers on this one. Let's see. What is our LCD going to be? Well, it's a repeat from one of our other problems, right? A 3 and 8 can both become 24. So the first fraction is probably easier. 3 can become 24 when you multiply by 8. So 11 times 8 is 88. So that's a repeat of what we had on the previous one. But here, a little bit more difficult. 8 times 3 is 24, so 37 times 3. Go into your margin. If you notice, you got some space here in your notebook, and do 37 times 3. I'll give you a moment. Go ahead and do 37 times 3. 5, 4, 3, 2, 1. 111. Now, if you notice, they're both positive again. So that means I can just add them up, which gives me 199 over 24. Now, on this problem, especially the word problem, we're going to probably want to write a mixed number. So you may need to ask yourself, well, how many times does 24 go into 199? Now, you can think about it this way. 24 is really close to 25, and 25 is a quarter. 199 is really close to 200. 200 is like $2. So maybe you think about that and see, well, if I do 24 times, well, how many quarters would that be? 8 quarters. So maybe in your margin, do 24 times 8, and that'll help you write your fraction piece. Your goal, again, is to try and find out what that numerator is going to be, because we know that the denominator is going to be 24. Oh, I gave it to you already. So again, do 24 times 8, and you should get 192. So it means we need 7 over 24, because 192 plus 7 is 199. And let's see, did our units? Yeah, our units feet there. So 8 whole 7/24 feet. Excellent. So on your assignment, again, we're going to be still using our integer rules. You notice we're going to do adding the opposite. We're going to throw in some decimals from elementary school, and definitely our fractions from elementary school as well. Make sure that you ask for help if you need it, please. All right, be awesome.